Good morning, everybody. Hopefully you're ready for another sunny day of organic chemistry with your host, Dr. White. Hopefully you had a nice weekend. I mastered how to use video editing software that the school gave me to use on my home computer. And I found out the U drive, which they have set up for large files, won't take files greater than 500 meg. And my video files are all larger. So in this never-ending saga, will I get my lectures online or not? Well, hopefully probably tomorrow afternoon I'll set up, I've already set up a name, and I'll start trying to I'll do it on YouTube, so you can do that. One interesting thing that I found out from editing the software is my bald spot is quite visible. So the rest of the semester I'm going to be writing on the board like this, or this spot is available for rent for any advertising, so if you know any companies that want to advertise, it's available. All right, as I promised, which is not the file I want, what's happening? Get the file I want. I promised I would go through the alcohol problem set, which I will right now. Remember, one of the hardest things for me to hear, and I didn't have a miracle this weekend, so my hearing is still the way it always has been for the last couple of years, awful, even with these, letter of the alphabet, so make sure you say it loud so I can hear it. And we'll do like we've already done before, one page at a time. And first page, give the IUPAC names for the following, A, B, C, or D. Does somebody have a favorite? You do C? Of course I can. Let's look at C. When you're naming a molecule, any organic molecule, the first thing to do is look for something different. It's not carbon or hydrogen. It's usually a good place to start. Also, it's not a carbon-carbon single bond. And if I look there, I say, ooh, oxygen with a hydrogen, hydroxyl by carbon, alcohol. How many carbons in the longest chain that has that carbon? 1, 2, 3, 4, 5. Pentane. Drop the E, add OL, pentanol. Which carbon is it on? Functional group carbons with the functional group, in this case an alcohol, always gets the lowest number, highest priority, therefore it's 2. Oh, it's your old friend, the methyl group is on carbon 3, so it's 3-methyl, 2-pentanol. And if while we're in the neighborhood, we go down to D, what do we have that's different? Again, hydroxyl group. And then what's the longest chain? Oh, it's on a ring, by the way. Those rings, so is Mother Nature. And how many carbons in the ring? 5. Pentane, cyclopentane, because the ring, don't forget the cyclo. And drop the E, add OL, cyclopentanol. No number is needed because the carbon with the hydroxyl group is always number 1. Everybody knows that. That's why they set up the rules that way. And therefore, are we done? No. We have on carbon 2 an isopropyl, carbon 3 a methyl. Now, I have 3-methyl, 2-isopropyl. If you put the 2-isopropyl first, I would count it correct, even though this is the only correct IUPAC way. All right, there are 2 types of nomenclature skills. Organic chemists, or people who know organic chemistry, like you are learning, should have. That means it's on the test, 2 types of questions. One is, here's the structure, give the IUPAC name. The other is, here's the structure, here's the name, you draw the structure. Now, anybody have one? A, B, C, or down here, D? You do C? Of course I can't really ask that question. And C, how do we decode the name to know what to draw? You start to write and go this way. OL ending, alcohol. If that were an E, octane, 8 carbons. Therefore, I have an 8 carbon chain, and on carbon 2 is my alcohol. Now, as I warned you before, how should I put this? Good habits I don't change, and I've learned, and I do, always write my functional group starting on the right. If you had written it 2 there, that would have been perfectly correct, but this is the way I'm going to do it. And therefore, 8 carbons. Carbon number 2 is my hydroxyl group, my alcohol. And then going this way, I have methyl. Well, you know what that is. Di means 2, and there are 2 methyl groups on carbons 3 and 5. Now, while we're in the neighborhood, if we look at this one, D, para, that means aromatic, para-isopropyl phenol. What is phenol? A benzene ring with a hydroxyl group on it. Don't forget to put either the bonds or the circle there, because if you don't, I'll mark it wrong, because that's cyclohexane ring, this is a benzene ring. Phenol, hydroxyl group on a carbon of the benzene ring, and then para means 1,4 disubstituted. This is 1, 2, 3, 4. I have my isopropyl. And that's how you have 1,4 para-isopropyl phenol. Oh, let's do F, because I'm in a good mood. I like rings. And if we look at this, it's 3-isopropyl cyclopentanol. OL ending, alcohol. That word E, cyclopentane, 5-membered ring. And one of the carbons has the hydroxyl group, which is number 1. And then on carbon 3 is isopropyl. Now, one of the things I've been doing on the problem sets is what I've been warned, but I've never seen it in the years we've been using it, that once in a while, ACS might use, instead of this for alkyl group, use the stick line method, which every bend in the line is a carbon, every intersection is a carbon, every end of the line is a carbon. And this is how you would do an isopropyl group. If I were talking to other PhDs, that's how I would draw it, because we're lazy. That's easier. Also, that's the way you're probably going to see it on the internet, because it's easier to draw, even with the software. And you'll see a lot of times I'll be showing you that. All right, let's get into the fun part of organic chemistry, and that's the reactions. All right, on my test, and coming up test number 2 in a couple of weeks, I'll post, but the points break down. But historically, generally in all of these, I'll have 3 areas: 1, general knowledge; 2, nomenclature; 3, reactions. On test number 2, historically, the reactions go up because they're going to be, and we'll be spending more time talking about the reactions, to 60 points. Nomenclature goes down to 35, and general knowledge is somewhere around 10 points. Speaking of general knowledge, anybody drive by a gas station and think they sell gasoline which contains ethanol, which is an alcohol? Oh, good, I see a few people saying yes. Anybody happen to look at your rubbing alcohol at home and look at the bottle and it says isopropyl alcohol, and that's an alcohol in that product? I see a few. Not more of you. Come on, think about it. It won't hurt. All right, let's get back to the problem set number 3. Give the organic product or products to a follower. How do you do this? Again, look for something different. What's not a carbon-carbon single bond, or carbon or hydrogen atom should get your attention like that. Who's working somewhere today? Like that. And therefore, if we look at A and B, anybody have a question either one want me to do? You do B? Oh, whoever's asking all these questions, thank you. All right, B. What do we see that's different? Double bond. What are we reacting with? Acid and water. Double bond, acid and water. Think of water as HOH. Break the pi bond. Each carbon gets something. One carbon gets H from the water, the other gets the hydroxyl group. It follows Markovnikov's rule. The carbon with the most hydrogens gets the hydrogen, and the other carbon gets the hydroxyl group. Oh, look, double bond. There are no hydrogen. Oh, I know how to count. There's 4 bonds to carbon. This carbon has 1, 2, 3, 4 bonds. 4 minus 4 is 0. This carbon has 1, 2, 3. 4 minus 3 is 1. Therefore, the hydrogen will go there, hydroxyl group will go there. There's a product. If you have these switched, that's fine. And that's how you do it. And this one was also on test number 1. And this is one of the few reactions I can have on more than one test in test 1 through 4. And I give you another problem right here. All right, D, E, or F. Any takers? I've got a taker. Which one?
D and E.
E?
D as in dog, E as in elephant.
What?
D and E.
What?
She said D and E.
Ooh, multiple choice. Well, it must be 2 for 1 Monday. All right, let's do D. What's the reaction? And by the way, I did this reaction last week in the lab, and I'd like to thank everybody for working safely with sulfuric acid. And you overcame some of your fears dealing with a very hazardous chemical, but if handled correctly, it's safe. All right, let's look at what's different. Hydroxy group on a carbon. What am I reacting this alcohol with? Sulfuric acid at high heat, which you did last week, and it's quite sticky as you found out. And here, what do we have? Carbon with a hydroxy group, adjacent carbon with a hydrogen. You heat it, you lose water, you get a double bond between these 2 carbons, it follows Zasev's rule. In this case, you don't have to consider Zasev's rule, because here is when you have 2 adjacent carbons with hydrogens. Here we only have 1, so I lose the hydroxyl here, hydrogen there, form a carbon double bond. You break carbon-carbon single bonds. No. So there's my alkene double bond. And that's how you do that one. Now let's do the fun one. And that's the next one, E. Now, E, Dr. White played a little trick. And the little trick is, here's an alcohol, carbon with hydroxyl, sulfuric acid, and heat. Here we have a double alcohol, lose the water, you get double bond. Here's the carbon with the hydroxyl group. What does the general reaction tell us? That an adjacent carbon must have a hydrogen. You need that. Here's the carbon where the adjacent carbons, this one and that one. How many hydrogens on that one? 2. Well, it's got a hydrogen. So if I lose this and the hydroxyl group, I'll form this double bond. You don't break carbon-carbon single bonds, so the methyl groups stay along for the ride, and they do. If we look at this adjacent carbon, how many hydrogens on it? 1, 2, 3, 4. 4 minus 4 is 0, so you cannot form a double bond. Gotta force my hand to do this because it's saying, no, don't. Notice something wrong here? 1, 2, 3, 4, 5 bonds have carbon. That can't happen. If you find a way of making that happen, let me know, and we'll be rich beyond my wildest dreams. That goes beyond having my own island, my own fleet of jets, my own Lamborghini and Ferrari, much more than that. It can't happen, okay? Yes, but.
If there were only one methyl group, the major products would
All
have
right,
a
let's
double
do
bond,
that.
right?
Let's find out. Assume there was only one methyl group here. That's the nice thing about organic chemistry. Go ahead and try it out and see what happens. And I have my hydroxyl group here. This would be one product or possibility. This would be the other one. Question is, the way I teach the Zasev's rule, which is the product you get? In other words, which would be the right answer on the test? Well, how do you apply Zasev's rule? You look at the 2 carbons of the double bond, and you say, how many carbon atoms are directly bonded to the carbon atoms of the double bond? Don't know, we can count. Here's this carbon, that's 1. This carbon, that's 2. You don't count this because it's not directly bonded to that carbon. So you see 2 here. Let's go here. Here's my 2 carbons double bond. 1, 2, 3. Now you have to use your high-level math skills and find out which one is the larger number. Time's up, hopefully you pick 3. And therefore, the way I am teaching Zay's rule, this is the product you get. And that's the fun of organic chemistry. There should be anything you can think of for a general, for a reaction, you should be able to figure it out. And if we look at F, same thing. Here's an alcohol reacting with sulfuric acid and heat, 2 adjacent carbon with hydrogens, A and B. And if we lose the double hydroxy group and the hydrogen from A, we get this alkene. If we lose it from B, hydrogen there, hydroxy group there, we'll get that alkene B. And notice, if I count the number of carbon atoms, that's 2 directly bonded to the double bond, 1, 2, 3, 3 is greater than 2. The correct product is, answer is B. And that's how you do it. I think I threw another one in at the end of the problem set because I was too late to do the alphabet. Ties everything. Secret. All right, G, H, or hidden at the bottom and the top of the next page, I.
H and I.
All right, let's do H first. What do we have? What's different? Carbon hydroxy group, alcohol. And it turns out it's a secondary alcohol. We're oxidizing it, that's what this means. To remove the hydrogen from the carbon with the hydroxy group, the hydrogen from the hydroxyl group, and you form a carbon-oxygen double bond. And therefore, here's my carbon, here's my R prime, doesn't change. I lose that hydrogen form a carbon-oxygen double bond. And that's how you do the oxidation. Now, if we go to the next one, I, now you're dealing with a primary alcohol, but the same thing happens. And technically I could have taught it at the same time, but I separated because that's how it's in your book, even though you didn't have to buy the book. And hydroxy group on a carbon, primary alcohol, use hydrogen there when you oxidize it, form a carbon-oxygen double bond. Oh, I promise I'd do this. Those who came in late, I was editing the videos and saw this. I think I can do the Mike Nesmith thing, which none of you know what that means, is to start wearing a hat. Anyways, here you form a carbon-oxygen double bond again. Do you break carbon-carbon single bonds? No. And uncharacteristically, I put the hydroxy group on this end. Normally I'll put it on this end. And you lose the hydrogen there. That hydrogen forms this carbon-oxygen double bond. And you have 4 carbons, and those 4 carbons are still connected because you still have carbon-carbon single bonds that you don't break. Yes?
Okay, so for that, the first part of that reaction, you have the O double bond carbon and then a hydrogen on the bottom of that.
All right, there are 2 types of things. I think I see your problem. First one we'll learn later this week. I'll get into it. This is called a ketone. This is called an aldehyde. They're different, but in some ways they're similar, and we'll learn later about that. But the first thing you have to remember is how many bonds the carbon form. And therefore, if you look at this, if I lose a hydrogen there, form a carbon-oxygen double bond, there'll still be 1 hydrogen on there, right? Because I only lose 1 hydrogen from here. And the same thing happens above. But on the carbon with the hydroxy group, you only have 1 hydrogen. You lose that, and the other one, you'll get that. Both are forming a carbon-oxygen double bond.
I guess I'm confused on why you're losing that hydrogen.
because that's generally what the reaction does. What I can't do is go into the mechanism of oxidation or other reactions. It's just sort of like, why does the sun come up in the east and not the west? Here in Chicagoland, or probably anywhere in the planet, I would think, but I haven't been everywhere. Because someone went into a lab, said if I do this and react it with this, what do I get? They do it with different things and they find out a trend or general reaction. That's the best reason to say why, because that's what happens in real life. All right. You have a question? I'll talk to you after class because I want to move on because I have a lot more to go. I'm not really, but I still want to get stuff today. Coming up, don't want to give away, but I have a really, talk about something that will just say, wow, we can talk about that. All right, let's move on to J, K, or I. Ooh, M disappeared to the next page, so we're going to do that. J, K, or I, or L, I'm sorry. Any takers? You do K? Okay, I'll do it. One of my favorite letters of the alphabet for obvious reasons. So is W, but let's move back to here. What's the reaction? The question is, give the organic product or bond. What's different? Hydroxyl group on a carbon. Oxygen should have got your attention like that. We're acting with thionyl chloride. This means if it's above the arrow, or if I put a plus sign, this reacts with this to give what? Thionyl chloride reacts by replacing the hydroxyl group with a chlorine. You break carbon-carbon single bonds? No. Therefore, at my ring two methyl groups, the carbon with the hydroxyl group will be the carbon that gets the chlorine. And the other ones are like the same. And as I talked to you last week, I think it was I mentioned, this or the next reaction is how the manufacturer Splenda makes the molecule that tells your tongue to tell your brain, ooh, this is sweet. All right, let's look at, this is M, and N or O. You can see I had trouble with my software doing a TBO group. That was not good, but that's a TBO group. Sometimes my software doesn't want to play nice. All right, N, M, or O. Any takers? Any questions? Can you do N? Uh-oh, I have that on videotape. I'm playing that. All right, what's different? Carbon, hydroxyl group. What are we reacting with? HBr. In organic chemistry, halogens are denoted by X. So I have alcohol plus HX. I don't have it on there, but I can do it on the whiteboard. For these reactions, X is chlorine, bromine, or iodine. What happens? You replace the hydroxyl group with X, you get water, but as you've learned by now, organic chemists are very biased. When it comes to stuff inorganic, unless you have to do it in a plant or lab, you don't worry about that. This is not either, so what happens, I replace the hydroxyl group with X. What's X? Halogen. It's on the same carbon that the hydroxyl group is on. That's important. Second carbon, and there's my thought. Any questions? And then in P, I said, I should give you another Zaysesrol hint problem that you need extra practice. And if we look at this, what do we have? In fact, I already did this one. Who asked the question, Beth? This is the one where instead of having the two methyl groups, you just have one. So I anticipated your question. I just forgot about, am I good or am I good? Don't answer it. All right, well, let's do this again. Hydroxyl group, sulfuric acid heat, you lose the hydroxyl group adjacent carbon, has a hydrogen, you lose that, you lose water, you get a double bond, follows Zaysesrol. Here's an adjacent carbon, here's the other one, both have hydrogens. If I lose the hydrogen there, hydroxyl group there, I get this double bond. The rest of the ring, the methyl group stays the same. And then if I lose the hydrogen from here, hydroxyl group, form double bond there, I get this. How many carbons are directly bonded to the carbons of double bond? In A, it's 2. Just count the circles. In B, it's 3, which is a larger number. Hopefully I'll pick 3, and that's the product. On the test, do you have to circle that or show all that? No, you just have to write their final answer. Any questions? Going once, going twice, done. As always, if I get here early, I'll be trying next week to get here early because we're going to get into some interesting stuff. Feel free to ask questions before the class or after lab too. Oh, good news, this lab, safe chemicals, so you don't have to wear any special clothes other than normally allowed clothes in the lab. And don't forget to do your to-do list, we have lab tomorrow. And don't forget Thursdays, people bring your to-do list and do your lab. All right. As I mentioned earlier, for those who came in late, hopefully by the end of the week, one way or the other, by Thursday or Friday sometime, I'll have videos of me online for your fun and enjoyment. You even get to see the part where the camera, I forgot to tighten the tripod properly, and it's all of a sudden the camera was going like this for a couple minutes. I put in there, oops, go to, yeah, you still hear me, but you can't see me, but all right, last week, if memory serves me correct, I had this reaction, and I just showed on the board that if you take ethylene oxide, which is 2 carbons in a ring with oxygen, and this one I'm writing on the board, you don't have to copy down. One nice thing about the video, you can see the stuff on the board quite well. I was concerned how well that would show up. All right. Again, you don't have to write this down. I want to illustrate an important point. If I take an alcohol, react it with ethylene oxide, I'll make this ether alcohol. I discussed this last week. And here's what you have. And notice on the end, I have an alcohol. So I can react that with more ethylene oxide. This reacts with this. This is my R group. And I'll get this molecule. And look, it's also an alcohol. And therefore, I can react it with more ethylene oxide. And this is my R group. And now I'll get this ether alcohol. And if you look at this, and it's a polyether, poly meaning more than one, so is that. This has an alcohol. And I can react it with more ethylene oxide. And I could keep on going on and on and on like the Energizer Rabbit, Bunny, and I won't, because this will illustrate a point. Notice 1 molecule or mole, 2, 3. I started with this alcohol, reacted it with 3 molecules or moles. Remember, moles are the counting units of chemistry and chemists. And notice here, I have 3 repeating units, O, CH2, CH2. And I could rewrite this. I don't know if you remember from math, 3 lines means exactly the same. Three repeating units, I could repeat it like that. And what this leads us to is the next reaction, which is quite important in our daily life. When you react ethylene oxide more than 1 mole with an alcohol, otherwise known as N moles, where N is the whole number from, I guess even 1 would work, but from 2 and greater. And even though organic chemists hate balancing, that N is important, and what you get is this poly, meaning many, ether alcohol. And these compounds are used in your daily life. Many of them are in your personal care items, such as cosmetics, hand lotions, conditioners and shampoos for your hair, a lot of other stuff too. So let's try one. Oh, I should let you know, as Dr. White's knows sometimes, that is on a test, these 2 reactions with ethylene oxide, I'll never put down as a synthesis problem, but I will put down as give the organic reaction a reaction. Or product with products. And I'll do this one. What do we have here that's different? Carbon with a hydroxyl group. What is that? Alcohol. What's my R group? Ethyl. What am I? Ooh, a number 5. And this is ethylene oxide, which you don't have to know the name. I won't ask you that structure on the test or draw the structure, but I will use it. And here we have N is 5. So what do I get? This polyether alcohol. What's N? 5. What's my R? Ethyl. I'll write it up here so you people by the wall can see it. And I have my bracket, OCH2, CH2, closed bracket, what's N? 5. And my hydroxyl group. And that's the answer. Now, I work for companies that have made this product, and we do others. And N can be anywhere from 2 up to realistically 50. They sell those products. And those are called, like 2 would be the 2 mole ethoxylate of that alcohol. That's how it's talked about. Where 10 mole, 15 mole, 5 mole is very common products they sell. And why don't you try this one? What would be the organic product or products for the following? Now we're getting into the good stuff. By the way, this is called an ethoxylation of an alcohol. Are we having fun with ethoxylation of alcohols? You bet we are. This I am. Remember when you're done, look up and smile. All right, looks like everybody's done. Let's take a look at this. Question is, what's different? Ooh, I have carbon with a hydroxyl group. This is an alcohol. Ooh, I've got a number in front of something. I'll call that N. Ooh, ethylene oxide. That's different. And what do you get? This polyether alcohol. What's N? 8. What's R? A T-butyl group. Therefore, I'm going to have my R group, because you don't break carbon-carbon in single bonds. I have my repeating unit of my ether here. And what's N? N here is 8. Then outside, not inside the brackets, common mistake students make on the test, is my hydroxyl group. Because if it's inside, that's a whole different animal that does not really exist. And that's how you do it. Now, what are the powerful strengths, and I'll use the term, and I really mean it, beautiful part of functional group chemistry, organic chemistry you're learning is, if something doesn't react with a functional group, guess what? It won't react with that functional group. So let's try the following. I'll do this one, then I'll give you one. And the question is, if you react this molecule with 3 moles of ethylene oxide, what do you get? Now, watch closely. What do we have that's different in this molecule? Ooh, I've got a benzene ring. But I also have a hydroxyl group on a carbon and alcohol. Does anybody here know a reaction of a benzene ring with ethylene oxide? Because I don't. It doesn't. Anybody know a reaction of an alcohol with 3 moles of ethylene oxide? Sure do. And therefore, what only will happen is this reaction, because this will not react with that and won't react with a methyl group. There's a general reaction. What's my R group? Even though it has a functional group, it's just part of the R group coming along for the ride. Therefore, I have my R group. The carbon with the hydroxyl group is the carbon bond to that. What's that? O, CH2, CH2. What's N? N is 3. And that's the molecule. Now we can get into some really complex stuff. So, key thing to remember is, if you have more than one functional group, which most of the semester we won't, but in real life you do, if you have a reaction or reagent, if it doesn't react with a certain functional group, guess what? It won't react and change things. The other part will. All right, now that you try one. You notice I'm writing bigger font because I noticed from the video it's even better is for you to see if you want to look at that. Why don't you try this? Oh, you're already jumping and doing it. Thank you. I'm so proud of you people. case you're wondering, this is a long R group, alkyl group on the benzene ring. It's called nonal. It's got 9 carbons, no name. Drop the E, add YL. Don't forget to put the double bonds inside the ring for the benzene ring. Really getting into the good stuff of working in chemistry. It looks like the last hydrogens are just about going down. All right, let's take a look at this. What's different? Well, I got a benzene ring, aromatic ring. Anybody think of cinnamon or vanilla? Think of aromatic compounds with you? That's last chapter. But anyways, benzene ring, ooh, ethylene oxide, will that react? No, but I have carbon with hydroxyl group, alcohol. I have, 9 moles, 10 moles of ethylene oxide. What happens? You get this polyether alcohol. What's N? Here. Well, first of all, we get this polyether alcohol. What's R? My benzene ring in the pair position along alkyl group. Here's my oxygen of the hydroxyl group. I'll have on there a bracket OCH2, CH2. What's N? 9. And outside the bracket, if you put it inside, I'll mark it wrong, is the hydroxyl group. Now, one of the things you should always be doing in my class is asking the following question. Why am I learning this stuff? And you know the obvious answer, so you get a good grade, impress someone, or get the credentials to get into the school you want to get into. But the other reason is really, why are you learning this stuff? Well, let's look at this reaction. Now, it turns out this molecule has a trade name, not a common name, a trade name of nonylphenol, or nonoxyl 9. And if you notice, if I start writing in there, Google will bring me right up to this page right here. Same molecule here, they're drawing it a little differently. You have your 9 carbons, every bend in the line, so it's a CH2, 8 of them methyl group. Here I have my CH2, CH2 oxygen, 9 hydroxyl group. This is called nonylphenol. Now, this is a special type of compound which we'll have a little time to talk about, surfactants. And surfactants are molecules that interact at the surface of things like your hands, your hair, and other places. I could spend a whole 2 semesters giving a course just on surfactants, and I still wouldn't get into it. It's one of my areas of specialty in organic chemistry. Now, throughout this rest of the semester, I'm going to talk about certain things that are in our daily life, meaning you can go to a big box store or other places and buy it, or see it on TV advertised. And I'm in no way taking position for or against based on for the school or myself, but this is stuff in real life. And where can you find this molecule that just learned how to make? It's called nonoxyl 9. It's the spermicide found on the outside of condoms. And if you go to your local big box store, and I'm in no way saying you should buy this, but if you go to this place like Walmart, you can pick up products and look at the back or the labels of ingredients. You'll see on the box in the front, spermicide with lubricant, the lubricated ones contain spermicide, and that's nonoxyl 9. How does this do this? Don't know. I'm not a biologist. I did read it somehow immobilizes the sperm, and therefore they don't travel, but I don't know if that's right or not. But I do know how to make this compound. I also know that it's used for many interesting things besides this spermicide. It's, like I said, on condoms and also in the foam for diaphragms, the jelly is the active ingredient. It's also used as surfactant, a lubricant in shaving cream, which explains why men's faces don't get pregnant, and also, anyways, and it's also most interesting enough as a surfactant. It's used in the type of products that if you get poison ivy and you're now killing yourself from the itch and the burn, you put this on there, and by being a surfactant, interacting with your skin where the chemical from the poison ivy is, takes it out of your skin, it's useful for that. So why are we learning things like this? Because you can use it in your everyday life to make things that people need to make, that we use. And I just finished the chapter on ethers and epoxides. All right, today's Monday. I'll give you till next Monday. Next Monday, I will be going through the ethers and epoxides problem set. Hold on, I still have a whole 120 seconds. Coming attractions tomorrow. I'll get to talk about aldehydes and ketones. I'm going to let you out a whole minute and a half early. I'll see you tomorrow. And next time you're in the supermarket or big box store, look at the labels for things. You'll be amazed what they sell. You'll learn how to make them more fresh. With that, I'll see you tomorrow.